Welcome to MyProjectBazaar.com. Now we discuss about the product for partially parallel encoder architecture for long polar codes. Next we see the abstract for the product. Polar code is a new class of error correcting codes that probably achieve the capacity of underlying channels. In addition to concentrate algorithm for constructing, encoding and decoding the code are all developed. Due to the channel capacity achieving property, the polar code is now considered as a major breakthrough the coding theory. This the applicable for the polar code is being investigated in many applications, including data storage device. Although the polar code achieves the underlying channel's capacity, the property of the asymptotical since the good error correcting performance is obtained when the code length is sufficiently long. To be close the channel capacity, the code length should be at least 2 power 20 bits limitations. Therefore, an architecture that can effectively deal with long polar codes is necessary to make the very large scale integration implementation feasible. Various theoretic aspects of the polar code, including the code construction and decoding algorithm, has been investigated in previous work. An efficient decoding structure has been studied. Successive cancellation decoding has been the traditional used in the an advanced decoding algorithm such as the belief propagation decoding. List decoding is the simplified has been the recently employed. Due to the channel achieving property, the polar code has become one of the most favorable error correcting codes. As the polar code achieves the property asymptotically, however, it should be long enough to have the good error correcting performance. Although the previous fully parallel encoder is initiative and easy to implement, it's not suitable for long polar codes because the huge hardware complexity required in the fully parallel encoder architecture. We analyze the encoding process and the viewpoint of the large-scale integration implementation and propose the new efficient encoder architecture for adaptive the long polar codes and effectively identify the hardware complexity and remove the overall process. Next we see the flow diagram for the product. Our flow diagram is 16 point of polar code based partially parallel encoder architecture. We apply the 8-bit input data bits for 16-bit level, 16-point level. Then we apply the each and every level to apply the single 8-bit value with different bit limitations, and to split the 8-bit input data bits into two levels, applying the first stage and second stage process. Because the polar code consists of 4-stage process for overall partially parallel encoding functions. Then apply the first and second stage. This stage consists of XOR gate design process and crosswise XOR gate designs process. These XOR gates used to distance calculation process for overall functions. Then to analyze these functions and to update the first and second stage results to the third stage functions. These third stage function to consist of second stage output and to the next stage weighted section element. This element to be processed by the 2:1 mux selection logic function with register element. This register element to be stored the previous stage results for different positions and to get the positions output and to process the XOR gate functions for bitwise distance calculations. Then the distance calculation to be passed by the fourth stage. This fourth stage to be consist of register elements and the mux selection logic and the XOR gate logic. These XOR gate logic to be reduced by the register element functions. This the third stage output weighted element to be passed in the two input mux. The selection control to be controlled by the each and every selection mux architectures. Then the without register element to be passed in the XOR gate functions. These XOR gate function to be describe the final data bits. These data bits to be get the final encoded data bits or polar code structure. Then to analyze the performance. This performance and simulation and synthesis analyze based on our overall performance analysis process. This is the final flow diagram for polar code encoding architecture. Then to see the final output for the product, we double-click the Xilinx ISC project. Our project was developed in Verilog language and to the Xilinx 14.2 software. We developed the encoder and both ways decoding function also. We developed the encoding architecture results then to simulate our encoding polar codes based on the overall architecture, then to run the simulate behavior model. Our behavior model is completed successful, then to create the ISM project navigator. This project navigator is used to simulate our overall data bits. We apply the data bits directly to our Verilog coding. So we apply the data bits already and to generate the final output data bits also. This the our apply the input data bits. This the controller for overall clocking function. This the finalize output. We set the clock into the 0. Then to be apply the reset is 1. Then selection logic to be 0. Then to run. Then clock to be apply the 1 position. We initialize the 0 level, then apply the clock is equal to 0, then reset function equal to the 0, then run and apply the clock 1 and to get the final encoder data bits. This is the overall simulation process for our architecture. This is the simulation output data bits. Then to close the simulation data bits and to select the implementation part. The implementation part to be selected the encoding architecture. Then to select the implementation process and to select the encoder function. Then to visualize the view RTL schematic diagrammatic representation. This is the RTL diagram for overall logical structure present in our required programming functions for polar code based encoding function architecture. Then to add and create, this is the encoding architecture. This is the register control element. This is the selection logic. This is the structure for overall polar code based encoding structure. Then go to the design summary process. This summary process to be presented what are the report to be followed over the architecture. This is the synthesis report. This is the device utilization summary for our 16-point polar code encoding architecture. Then go to the timing summary. This is the required clock frequency, speed level and the timing. This is the overall combination path delay time. This is the latency timing for our overall polar code based encoding architecture. And also you see the technological diagrammatic representation also. This is the technological diagram for overall architecture. This is the final synthesis result for required polar code based encoding architecture.